equal and unequal cost we finished, right? Load balancing we finished. We saw metrics also. Can you see my screen? So Eigrp, anything sir we have left out? CCNP router. 98. Okay. Which one? This is okay. This is wrong actually. Some wrong message there. Load balancing. This is it. This is correct. This is correct. Stuff is correct. Load balancing, we studied equal and unequal load balancing. Remember? Okay. What is equal load balancing? No. What Eigrp equal load balancing? Tell in Eigrp language, not general. What is load balancing? Load balancing, equal load balancing. What is equal load balancing? What is unequal load balancing? In Eigrp, we studied last class, right? So it's unequal load balancing in Eigrp. So equal load balancing in Eigrp is what is equal load balancing? If the FT is same in two routes, what level? In topology table. Okay, if the FT is same in two roots in the topology, both roots will come to routing table, and as you said, it will share the load packets 50-50. Needs to, right? Okay. This is called equal load balancing. It will happen automatically. Okay, no need to configure. By default, it will happen. Okay. If by default, no need to configure this. If the okay. This. Next, what is unequal load balancing? Okay, so if FT what is the difference between load sharing and load balancing? Okay, load balancing? What's the difference? Okay. Load balancing. Half the packet. You break the one packet into half. Okay. What is load balance shading then? Okay. So load sharing cannot be performed on packet basis. Load balancing can be performed on packet basis. Okay. Load balancing is packet. Now Eigrp will do that. Eigrp is doing load balancing. Okay. Eigrp is doing what? Load balancing. Load sharing is something like I have 10 PCs are going. For example, Ether channel you take, right? Ether channel is doing load balance, load sharing. For example, Ether channel you take five Ethernet links and you plunging into one channel, right? Now, when you send a packet in Ether channel, it will create one PC, one link it will create. It will use another PC, next link it will take. So PC by PC or Mac by Mac, not PC, Mac by Mac. Mac by Mac, it will divide the link. So you take one link, I will take other link. You take next link. Like that, it will share the links, share the link, not the packet. Okay, that is called the load sharing. Load balancing means using CEF. You remember CEF, right? Using per packet CEF switching will happen. Understand? Per packet by packet. Packet by packet we take. Packet by packet, it will send it to one packet. For example, one PC is sending 10 packets. It will divide into. 5 packets will go to first link. Second packet will go to second link. Understand? That is load balancing. Understand? Okay. So as I mentioned here, it utilizes source and destination IP or MAC address based on destination while the load sharing. So it will use MAC address or IP address. That's it. Based on that, it will select which link you want to select. For example, you say this link, then this link go to. This is permanently for this link only. Understand? This load sharing. Clear on this? Okay. Now we are doing what? Load balancing. So load sharing means link. Load balancing means that. Just to make you understand. Okay, next. Next. Clear on this? If FD is not saved by default, I'm not going to configure anything, okay? By default, FD is not same for two routes for same destination. Destination is same, okay? If FD is not same, what will happen? Eigrp will find the test FD, find the successor and send to routing table. Correct? Only one route will do. Okay. Now I want to send both routes to routing table. If we need to send both routes from topology table to to routing table, right? What will happen? Then we use here, we use what command? Variance command to send both routes. Okay. So what is variance commands? Which multiplier, metric multiplier. Okay, variance is metric multiplier. Okay, clear on this? This is equal load balancing and unequal load balancing. Okay. Okay. Next topic is if FT is not same for two routes of the same destination, easier to find XSL and send to only one route to right, one route to routing table. If we need to send both routes from topology table to routing table, what we need to do? Got my point? If we need to send both routes from topology table to routing table, then understand, no? So that is called unequal load balancing. Now I am going to send both routes, but by default their metric is not same. Their metric is different. But I want to send both the routes to routing table. Then we use clear on this? Next we will go to Eigrp metric. So load balancing time, we go to Eigrp metric. Now tell me, what is Eigrp metric? K value. Okay, good. So what is this K value? Broadband. What is broadband? Link speed. That is broadband or bandwidth. Bandwidth is different, speed is different. I told you, right? Link speed is different, bandwidth is different. I explained you the road example also. Road size is bandwidth. How much speed you can go, the road can support is speed. That is speed. So now first, what is metric? Metric means what? What is metric? Metric is a parameter to select best route, right? What is metric? Metric is the parameters to select best route. So the metric for Eigrp is K value. Okay. Formula is by default gives us bandwidth, delay, okay, on demand you can use what? Load reliability what is load? First, what is bandwidth? Size of the link in kilobits per second. Okay. What is delay? What is delay? Round trip time in milliseconds. Next, what is that? Round trip time. Tell me. What is RTT? Okay. You are creating new abbreviation. Okay. Delay means the packet is going and coming back at how much milliseconds will take. Okay. Round trip. You are going and coming back. How much time it is taking? You are going to your office and coming back to home. How much time will it take? That is milliseconds. That is delay. Next. Load. What is load? Percentage of traffic in lane. That is, you put 255. 255 means full load. 1 means less load. Understand? So 1 to 255. Dash of 255. Like this. 255 means full load. Next, what is reliability? So, percentage of downtime. How many times it is going down, coming up, downtime in 1 hour or 1 minute? How many times it is coming down, going down? Understand? That is called the reliability. How it is? Same like 55 with 55. Okay. And what MTU? What is MTU? Maximum transmission unit. Transmission unit, right? This size maximum size of data per packet. Understand? What is this? Maximum per packet. Okay. So for example, one packet you say, what is the maximum size you can send in that data size? The data you can send. That is MTU. 1500 bytes. Comes in bytes. Okay. By default. That is MTU. By default, okay, values K1, K2, K3, K4, K5. What is K1? K2, load. K3, delay. K4, reliability. K5, MTU. Okay. Now, formula if you see, it is actually k equal to 1, k1, k2 0, k3, the default it is, okay. K3 is what? 1, K4 is 0, and K5 is 0. So formula goes like that. So metric equal or K value equal to bandwidth into 0. Something like that. Detailed formula we saw, right? 2 power or something like that. This is the way it works, because by default you are actually making load 0, reliability 0, empty 0. Only K1 and K3 you are keeping up own 1. So as per the formula, what happens? It will only work on the K1 and K3. Means what we are trying to do is that we are going to use this 2 and find the best K value. This is going to be find it. So total formula we have, right? So we saw the formula. Yeah, this is the formula. So like this is the final output. I'm just giving you a simple form. So if you go real formula, it will be very big. Simple way of understanding what is, how the metric is. But if you change it to K3, K4, then K2 and K4 and K3, then the value change. But by default, this is the understood metric. Okay, fine. Next we will go to IPv6. I told you after OSPF, I will teach you IPv6. Let us do first OSPF. Okay, OSPF, if you see, describe OSPF packet types. Okay, this topology ready? Samir, topology ready? Okay, so okay, you do tomorrow. Tomorrow we'll see. This is frame relay, understand? So we are going to use frame relay also. Side frame relay, like we have to do. So try to make this. Okay, I'll also make today. I'll also sit and do today afternoon this lab myself also. So both of us will do it. So if possible, we use yours or mine, whichever also. Okay, and I'll teach you the theory part today. So tomorrow we will start the labs. Okay, fine. First, OSPF is Open Shortest Path First. Open Standards Based Interior Gateway Protocol. It's an open standard protocol. Eigrp is Cisco proprietary. This is open standard. The RFC number is 2328. Okay. The protocol is using algorithm called the Dijkstra algorithm or SPF algorithm. Dijkstra is the Russian professor who invented the algorithm. Okay. So Dijkstra algorithm or SPF algorithm. This is a classless routing protocol. OSPF is a classless routing protocol. It supports VLSM and summarization. Meaning, like RIP 1 will not support classful routing protocol, right? It's a classless routing protocol. Okay, fine. And it supports a guarantee loop-free topology like Eigrp. It also does this. Okay. The first reason is all routers agree on overall topology. then it uses the algorithm. So it's not like that I am going to send the route, you are going to send me the route. First of all, we are not going to use this sending the routes concept. So there's a difference between EIGRP and OSPF. Okay, let me explain you this. Let's see how you are understanding that. Okay. Now, if you take a router like this, you need to tell me how EIGRP will work, how OSPF will work. Okay, now we are going to discuss this point. So this will give you a lot of idea for you. Now, R1 is going to send data to there is a PC here. Now, my question is how the routing updates will go between R1 and R2 in EIGRP first. So as we say like 10 dot 0 dot x dot host name or link host slash 24. Okay, now this will be like 12.0. You know, right, the schema. Okay, this is 3.0. Then we have 34.0. 45.0, sorry, 45.0, 26.0, 6.0, and 1.0. Right. Now R1 will send data to where? Okay, first neighborship. See, first question is how EIGRP will work is they both will become a neighbor, correct? This guy will become neighbor, he and he will become neighbor, and he will become neighbor, correct now? Is it right or wrong? Okay, this is neighbor, and this is only neighbor. Now neighborship, this guy, what he will do, R1 will send neighborship form, then he will send one route, 1.0, because 12 is directly connected, he will not send that. So it will send one update to 1.0 to R2, right? Like AFA0/0 for example. Right. Now what R2 will do? R2 become neighbor with R1. R2 will say, okay, see, R2, okay, no, not neighbor. Neighbor he will not say, he will give the routes. He will not say any neighbor details. He will say what routes you want to share. So for example, let us go like this only, one shot one. R2. Now R2 has how many routes? 12.0 and 1.0, two routes. 1.0 he got from R1, 12.0 he is directly connected. So now he will send the two routes, 1.0 and 12.0, correct? To R3. Now R3 will send how many routes? So 1.0 to 23.0 will send. Then R4 will send 1, 2, 3, 4 routes, correct? This guy will send 5 routes. Right. Now he got all the roots from R5. So who gave him the roots? All 5 roots? R5. R5. Now if PC1 want to go to 1.0, 1.1, ping 1.1, R6 don't know it is connected to R1. What R6 knows is, it is, if you send me R5, R5 will send it to him. That's it. He don't know the whole topology detail. What he knows is, if I give to R5, R5 will send it to him. That's it. Because he has this 5 roots he got from R5. So the root is okay, I am giving you, okay, this is the roots. So I will send back to R5. So R5 is my next hop IP, correct? He is saying I am going to send, so it's my next hop IP. Once R5 gets the root, then it will send it to whom? R4. Because R4 only know, R5 knows only it's coming from R4. So he don't know. Now this is the way it works. Understand this? So these people like R5 don't know the full topology details, where it is connected or it's connected. Understand? So this is the way Eigrp works. Now what happens in OSPF is, OSPF will not share the roots like this. These are our roots, right? Sharing the roots. What OSPF will do is, OSPF is something different. Okay. Here also will become neighbors. Okay, neighborship will form. Once I become neighbor, I will ask him, shall we share the topology? They share the topology. So what our topology he is connected are to this and this. So he will build one tree. See, R1 what he does is, he builds one tree. It starts from 1.0. Then it is connected to 2. Like it comes to R1, R2. Now R2 has 2. Now from there, like this he builds R3. So it has 3. I'm just writing like this. So but the point here is, it is building a tree. Short part like STP they say, it's a tree, OSPF tree it will build. So this topology tree will be built. So I'll get neighbor he will say, boss, this is my topology, he will get it. Then he will build the tree. Okay, I have connected here. Next, this guy will become neighbor. And he will build the tree here. So like that, they all build. So once this all guys become neighbor, they will, what they do is, they know full tree ready. Now like R6 also knows there is a PC connect, there is a link in R1, this tree, right? It is connected to R1. R1 has a root at 1.0. Who knows? R6 also knows the whole topology. Yes, it maintains the topology table, full topology. See, Eigrp also maintains topology, but the difference is, Eigrp only, topology means all roots for him, that's it. But it actually doesn't have like this type of tree built. You got the difference here? OSPF builds the tree, Eigrp gets the all roots in topology table. Now OSPF doesn't take any roots from anybody. First thing what it does is become neighbor and you will form the tree. Once the tree is ready, right? Once the tree is formed, then every router individually runs the spanning tree SPF algorithm, right? So now I am not going to ask anybody what is the root of go to this. No, nobody is giving any root to anybody, right? It will just say, okay, you want to go to one dot network as per my topology, you can go like this. He will give you the best route for it. So in routing table, you have a, like for example, you have a neighbor, you have 3 tables, right? Now I have a full topology that is called a link state database. This is neighbor table, right? In this database, for every route 6.0, 56, for this is for like thing like R1. Okay, for R1, for every route, it will run the SPF algorithm and find the best route and put it in the routing table. Now, the routes are not coming from neighbors. The routes are coming from my topology table. So there is a linked state database table. We call it topology linked state database table. In that table, the whole topology is available. For whichever whichever networks you can go, all the best routes are used to SPF algorithm and find and put it in the routing table. So now there is no way you will create a loop in this, because everybody runs the same algorithm, everybody has the same topology, so there is no way we can create a loop. Understand? So when loop will come? When loop will come? When loop will come? You give some route, wrong route. When a neighbor router gives wrong route, then only loop will create, no? But here we are not asking anybody route. We are building the topology. Once everybody has the same topology, then running the SPF, we individually going to find the best route. Every router. Yeah. Okay, now STP. STP is L2 technology. For same thing, STP also same thing, but for switching. Switching is for switching L2 loop, no, we use STP. For L3 routing loops, we use yesterday last class we studied. Remember routing loop algorithm? Before this we studied this routing loops prevention mechanisms, split horizon, like STP, like STP that is. But in OSPF that is not going to come up, because there will be no option, no way we will get the loop creation here, because we are not going to share the routes to anybody. Yeah, it builds its own topology, overall topology. So first they will agree on overall topology. Once they agree on overall topology, then the algorithm will run. After the algorithm finds the best route, that put it in the routing table. So there is nothing like routers are sharing the routes. Now what they will share then? Then there is nothing happens between routers. Yes. What they share, I will tell you. They will share, like for example, he will share, they will share something called LSAs. What is LSA? Link State Advertisement. Now this link is there, right? FH0. The link is down. Now it is R1's responsibility to tell everyone, sir, I gave you one link, right? R1 FH0/0, right? This link went down. I'll give you update, LSA update. Okay, so this LSA update will LSA flooding will say. LSA will go to everybody, and everybody will their topology remove this. Oh, in the tree there was one particular link was there connected to R1 that is failed. So like this is LS6. So OSPF sends not routes. OSPF sends what? LS6. So OSPF sends LS6, not routes. Going to center. If you only say I have in your topology, you correct your topology, because initially I gave you one link. I said in R1 in the tree, R1 has FA0, right? I told you, right? That is gone now. It's down now. That you please update it. So that is the LSA update it will send. So it will never give you what route connected, what route removed, what is the network. That like Eigrp RIP is doing, like that. It will not give any routes. It will only tell the link is up or down in the topology tree, in the tree, right? Link is up or down. The link, in the tree, one link is down, or again the link come back. If the link come back, right? Then you say, oh yeah, link is back, please. No, link is back, please update it. You understood? So link OSPF will give only what do you say? OSPF will give only LS6. Okay. Next. Now OSPF uses areas. What is this areas? For example, we have thousands of routers. See, OSPF is developed for very huge networks. So now OSPF is developed for very huge networks. The problem is we cannot actually send all the details to everybody. Like when I am giving an LSA, I don't want to send that LSA to everybody in the 1000 routers. Okay, so I need to segregate. So what I will do, I will take for example 1, 2, 3, 4, like this 5 routers are there. I will make this one router as one area, this 3 as one area, this as one area. Now what I will do, I will connect like this. Now this area 10, area 20, area 0. Okay. Now this area 10 router will give only the updates within this area. Now we have multiple routers like this, right? Now this guy will not give all the routes to this other area. What he will do, this router will actually reduce the summarization and give only one route, summarized route to neighbor, this other routers. What is single area? What is the disadvantage? See, now you have one, okay, I don't know what you are saying, you have to check that. Just show me the article. Okay, now you have one Bangalore. Okay, Bangalore is one city. Now this Bangalore have how many houses? How many houses we have in Bangalore? Approximately. Millions of houses. Every house will have one address. Okay, now if I start giving address 1, 2, 3, 4 like this, it will be easy for me to maintain. It's easy for you to maintain this. In all the houses single. Bangalore 1, Bangalore 2, Bangalore 3, Bangalore. Like that, can you give address all over all the houses in Bangalore? Then why we are creating areas? Just now we create areas, right? JP Nagar, Jaya Nagar, right? So in that area we give streets, right? Sector streets, blocks, whatever. So many areas we are creating. In that area we are giving these numbers, correct? This is logical division for easy management. If you logical division, area is what? Logically, we are not physical. Logically, we are dividing for easy management. Right? We have areas like based on pin code, right? So pin code says, right? What is the pin code? 56. So this pin code says what is this area? 1 means what? 2 means what? 3 means what? 69 means what? Right? So this pin code will really help you to build the area. So based on this pin codes numbers are there, no? That is area numbers. So what is the disadvantage of one area? If you have one area means Bangalore means only one area. Then what is the disadvantage? Think without any other areas, only one area, Bangalore. If you go to villages is only one village. There is nothing like in village inside that so many areas will be there. Total 50 houses will be there. Total 50 houses will be there. The 50 houses, how many villages will be there? That's it, no? You got my point? Understood what I am saying? So if you see one village, one village is a small 10 houses are there, 50 houses are there maximum. Further you need to create areas. But if you go for a big city like Bangalore, we create multiple areas, correct? Understand? So same way, RIP is only 15 routers. RIP is only 15 routers. My hop count is maximum hop count is how much? 15 routers. So 15 to 15 routers, if you want to cross, you don't need to create areas in that, you know. You got it. But OSPF is not like that. OSPF is built for huge network. So there, logically, we need to divide it. Understand? Thousands of houses, 10,000 houses are there, 10,000 routers are there. There you are better to divide into small areas. Easy management. Now JP Nagar, Jayanagar election is going on. So if something happens to Jayanagar, only Jayanagar will be affected, right? So again, now we don't need to stop the whole Bangalore election, no? You understand? You got my point? So you don't need to stop for the whole Bangalore election, no? You understand what is the area means? Okay. You are clear or not? Still not clear. Are you clear? Okay. So the benefit of area is, one of the benefit is topology summarization. You don't need to give all routes to everyone, summarize that route and send it to that. Okay. Now fast convergence. We manually configure it. Administrator. Bangalore is called OSPF network. OSPF network. There is a core network where everybody is connected. That is like, for example, you say Majestic. Example. That is backbone area. Area 0, you can say backbone area, right? So that is the base, center of the network. Center of the city we say, no, generally post office. Generally post office. Initially when they designed the cities, the area 0 is post office. That's why that number starts, 1 starts in post office only. You know, Vidhan Chowdhury, near Vidhan Chowdhury post office is there. That is first pin code number 1. Pin code number 1 is always post office. Every city will have one post office. The post office is the backbone area. From there, everybody connects. That is the way they design. For example, you can take Majestic also. Understand? So it's a logical division for easy management. One of the best benefit is like topology summarization. Second benefit is the LSA will not travel to everybody. Now, as I told you, Jayanagar, this is happening. So this van will not come to every area. Only Jayanagar they will travel, right? The LSAs will go. The advertisements will go where they are calling, they are talking to the phone, they are talking, like they are running the vans, campaigns, That will happen up to where? Only Jayanagar, no, because that is only that area is updating now. You got it, na? So the same way, when something goes up or down, only that area LSS will be traveling. The updates will go, advertisements will go only to that area. So unnecessary other areas will not be affected. So that is the way they have designed it. For bigger networks, we divide into areas in OSPF, because as I told you, OSPF is developed for bigger networks. It's not for small networks. Small networks we have Eigrp and Eigrp. Understand this? Any other doubts you have? Any other doubts? So it is OSPF is open standard protocol, standard based open standard. So you can use Windows, we can use Cisco as well as Juniper. Okay, it will not give any problem. So between different vendors, OSPF will work. But if you go for Eigrp, it will work only with Cisco devices, Cisco router to Cisco router only. Eigrp by give, now it is open standard. But if you are using Eigrp, I am just giving an example. Eigrp is a proprietary protocol. If you are using that, it will be between, you are working only single vendor. Okay. Now Eigrp is coming up open standard, but still, though we call it as open standard, but still, because they want to, there are now competition started, right? So they want to cover Cisco wants to cover the existing customers. They are saying, okay, you can go for other products also, we will support. Understand? Cisco is telling. Initially they are the monopoly, so they are holding like that. You understand? No? Now people are coming with different, so they want to protect that their share, so they are just going to open standard. Okay? Clear on this? Now fast convergence. Now actively track neighbor adjacencies. Now as I told you, one neighbor, one link fails, automatically the LSAs will come and update. Understand? Any event happens, it will send you the updates, LSAs. Okay. Now it will do updating will be done on both ways. It uses the reliable multicast and the unicast updates. Both it will do, unicast as well as multicast also. So unnecessary other devices which are not running OSPF will not affect by the updates. You got it now? When OSPF give LSA, the OSPF is going to give you on multicast. If you want to specifically want to send to one router, then you can do unicast also. Both OSPF is support. Right? Like remember, to 224 something like 224.0.0.10, right? Like that it sends. Like Eigrp sends. Same way, this also 10 is like that it will send. Okay. It will send you the exact router IP address. If no, it can send multicast. Like only OSPF devices will work, will update you, receive the update. Unnecessary others will not receive and direct and discard. Understand? And the metric is very simple here. Just take the bandwidth. Highest bandwidth is the metric. Hello? Cost is nothing but bandwidth. Cost is bandwidth. Okay, that's it. Next, it will support the manageability like control plane security. Like we remember, like we did in Eigrp, same way we can do here also. Right? Authentication we can do. Now, Eigrp supports MPLS also. Yes, it will support MPLS also. Okay, just a moment. There is a door is hitting. I just connect it. Hello? Hello? Yeah. Eigrp will support, OSPF will support MPLS traffic. Because it has an extra one field. If you want to add, you can add in the field, and that will support you for MPLS traffic also. Okay, it's extensible fields are available in OSPF. It's open standard, right? You can add extra fields also in the header format. Understand? What is MPLS? What is MPLS? So it will add a label to the packets. Based on the label, you do the WAN routing or WAN switching. This is switching. So based on the label, we do the switching. Okay. Now OSPF will say, okay, you want to do run MPLS. Okay, I'll give one field for you. You put that label in that field. Okay. So OSPF has that option available. So you can add for that. If you add that, it will give that link also. The option is available in the OSPF. Extensible link fields are available. Okay, for MPLS traffic. Clear on this? Okay. Now, distance vector routing protocol. We are going to discuss this. RIP version 1, version 2, Eigrp. These all are using Bellman 4 algorithm. Routers only know what directly connected neighbors. Neighbors tell them routing by rumor. Entire routing table is periodically advertised on hop-by-hop basis. Limits scalability. So loop prevention mechanism. What it is using? Split horizon, Poisson reverse, hold on timers. Okay, so this is the distance vector protocol. If you go to link state protocols, OSPF and ISAS is there. It uses Dijkstra shortest path algorithm. Guarantee loop tree calculation it will do, because I told you it will not give you any routes. All over the topology will find out first. After that, it will go to running. Attributes of the link states are advertised, not routes. Very important. Attributes of connected links is advertised, link states are advertised, up, down. It is not advertising the routes. Okay. So once routers agree on the overall picture of the topology, then before making the decision. Before making a decision, what is the best tool? First of all, they will agree on the topology, picture of the topology. The tree has to be seen. Okay. Next, form adjacency relationship with connected neighbors. Okay. Adjacency exchange link attributes in the form of link state advertisements, LSAs, LSPs with neighbors. Store copy of the LSA in the link state database and form a graph or tree, whatever you say. Run Dijkstra algorithm to find the best shortest path to all links, since all routers have same LSBD and SPF formation or loop field. Clear? Okay. That is which is storing in the LSBD. Now every neighbor will give its details, right? Its advertisements. What are the links he is directly connected? No. So that all it will create one map, graph or tree, whatever you say. Right? Clear on this? Okay. First, how OSPF works. Discover neighbors, exchange topology information. Okay. Second, choose best path via SPF. Third, maintain the neighbor and the topology table. 3 steps. Okay. Huh? What is it? No, there is second step. No? Second step is what? Selecting the best path, no? Routing. And put it in the routing table. See, first I am making a neighbor. Second I am exchanging the information. Now I got it, yes, done. Step 1 is done. Now I got the database ready, LSPD ready. Then I will select the best path using SPF. What I will do after selecting the best path? Stage 2. No. Second step, what it will do? No, not neighborship forming. Neighborship is formed here itself, step 1 itself. Neighborship table updated, topology table updated. In the topology table, we have the tree ready. In the tree, we are finding the best route, best path. Right? So then after finding the best path, the second step, what I will do? After that, after choosing the best path, what routing table will do? Route OSPF will do. Now I know this is the best path, what I will do? Tree formed, that is second step. See, tree form is here. Let me write down here again. See, there are steps here. I am going to break this change. I am going to break this step 1, step 2, step 3 into small pieces. Right? Okay. Now, first what? Discover neighbors. Okay, now I discover the neighbor. What will happen after neighbors are discovered? What OSPF will do? Which table it will update? Routing table, neighbors for neighbors. For neighbor table will form. Okay, good. So neighborship is formed, but neighbors are formed. After neighbors, from neighbors what I will get? LSAs. Right? A neighbor will give what? Now two routers are there. They are connected. Then first they become neighbors, R1, R2 neighbors. Then what will happen? It will update in their neighbor table, neighbors table. What it will do? It will update R2 is my neighbor. Correct? Same way R1 will R2 neighbor table it update R1 main neighbor. Correct? Now next what will happen? Topology table. We call it as LSBD here. LSBD, links to database. BD. Right? Now what will happen in LSBD? You will give a LSA. You will give LSA, right? This is the exchange topology information. This is 1. This is 2. Correct? Second step. Now once the LSBD is updated, here also LSBD updated, what will happen? Next what happens? Yeah, now in the topology table or LSBD, we will run the SPF algorithm, stage 2. Right? We will run the SPF algorithm. When you run the SPF algorithm, right? When you run the SPF algorithm, what will happen? Yeah, we selected the best part. What will happen next? No, not maintenance. I am asking here. Important point I am asking you. I am dividing this into small pieces now. I am not telling the same thing here. I have to tell me the tree is formed here. This is tree. LSPD here is tree. Yes. Only 3 tables, no? No. Then, yes, best path will put it back. This best path will go back. Yes, it will go to routing table. This is stage 2. So we have a routing table. In the routing table, the best path will go. Correct? Where it will go? Routing table. Nah? So once it goes to routing table, now the router will start sending data, receiving data. Let it start. Now going on. Now this is done. Now this link went down. R1 some link went down. It will send on LSA. Our neighborship itself is down. Correct? Neighborship itself is down. Itself is down. Then who will maintain this? Now we have to update. No, neighborship is down. This router is removed. So that is called a neighborship and topology maintenance. Link is down. Our neighbor itself is down. Who will maintain this? Any change in the topology or any neighbor is down. Who will maintain this? the OSPF has to maintain that. It depends on that, it keeps on updating the tree, this tree, understand? Now the tree changes, the route what it is sending will stop. For example, this link went down, the route will be removed from the routing table. Understand? Because there is nobody is going to give route. It has to update here. If it is done, he has to remove the route. Understood or not? So, neighbor and topology table is very important. Topology maintenance is very important in OSPF because neighbor is not going to give any routes. Clear on this? Okay. Next we'll go to how neighborship or topology forms details. Now, like Eigrp OSPF, OSPF also send hello packets. Hello. It uses the transport protocol, and the IP is IP protocol, that is a protocol number 89. Okay, and it's in 5 and 6. Okay, it uses 5 and 6, two multicast addresses or unicast, and the hello packet contains attributes that neighbor has to agree. I told you, remember, when you send a hello, you need to agree on some attributes. If the attributes are agreed or same, then only neighbor adjacency will form. Understand? Once the adjacency is negotiated, LSBD is exchanged. Okay. Now once LSBD is exchanged, OSPF occurs when the neighbors hello packets agree on unique and common attributes. Okay, there are two attributes are there, unique and common attributes. What is unique? Both must not have same. Different. That is unique. Common means both R1 and R2 both must be same attributes. Like area means same area. Password must be same, common. But router ID, name of the router must be different. IP address must be different. It cannot be same. No, that is unique. See, some attributes must be same, unique. Some attributes must be common. Okay, remember, all OSPF neighbors actually form. Not all OSPF neighbors forms adjacency. Okay, there are 2 points here. Try to understand here. Okay, I'll use this paint here for this. Okay, now I am going to become these two guys. One more link I'll form like this. Now this router and this router. Okay. Now these two routers, we are going to talk to each other and we become a neighbor. He also neighbor, right? This both are talking. So he also neighbor. Now it is not mandatory. I will share all my details to this guy. Okay. It's not all routers are become adjacency. Okay. Adjacency means what? Adjacency means I will share my LSBD. Okay, so this two is not adjacency, they are adjacency, for example. Neighbor and adjacency. So that is the point here. Not all neighbors are actually form adjacency. I'll tell you where it will form, where it will not form. Okay, then we'll discuss that point later. But remember, as of now, don't think that all neighbor means once you are my neighbor, I will not share all my details to you. Correct? There are only few people will share all the details, right? Whatever I please, whatever information I know. Right? You are neighbors, that's it. You are not adjacencies. Most OSPF configuration problems happens at this stage. Okay, remember, when the neighborship is forming, right, there is a lot of, for example, 100 OSPF troubleshooting is coming means, in that 99 will be forming neighborship only. So only 1% apart from this. Okay. So 100 tickets are coming, 99 tickets are only forming the neighborship itself. Okay, once neighborship is formed, then the attributes are shared, properly shared, then there is no problem. Instead, it's good to run OSPF and give the output to the routing table. Correct. Okay, next, unique attributes include two. Router ID and OSPF. Okay. Now, what is this unique ID? router ID. What is router ID? Yeah, name of the router for what? For right, name of the router for OSPF processes. Let me write down here. What is router ID? Now it is the name of the router for OSPF processes. OSPF is going to do a lot of processes. For that we are going to use one name. The format of the name is IPv4 address. Okay. Understand? The format of the router is IPv4 address. Okay. Example you can do like this: R1 1.1.1, R2. Yeah, it has to be unique. So 2.2.2 like this. Then local interface IP addresses. So how do you configure this? It will happen automatically. Automatic. One option. What is that? It will find by automatically. It will work based on configuration. Okay. One is highest IP uplink IP address, or second option, or second priority, highest loopback interface, link interface, uplink interface, loopback interface, IP address. Automatically takes IP address. For a scenario like this, IPv6 or some scenario, if it is not possible, then we have to do manual configuration. How to do that? Using a command called router ID command. Okay. Read it out. Right. Next. Okay. This is router ID. You want to write down this? Okay. Next, common attributes. It must have a same area, same hello and data interval timers. Interface network address must be same. IP address must be different, but network address must be same. And MTU must be same. Network type must be same. There are different network types. Remember, this guy OSPF actually it's a media dependent protocol. If the network type changes, right, it will not work. For example, broadcast network, one type of network, or point-to-point network, point to multi-point network. Just writing something like this, like it's not point-to-point actually. It is something like MBMA, non-broadcast multi-access network. Like that, so many network types are there. We'll study this later. If that has to be same has to be same network, same type of network. Okay. Authentication password. Then flash stub. If you configure stub, remember stub? If you configure stub flash, it must be same. Then only neighborship will form. Understand? These all things you need to remember when you are doing troubleshooting. If you understand, no, if one of this is not correct, common, then it will not form the neighborship. Click on this. Okay, now hello packet will send these many details. Okay, so OSPF router sends hello packets, router ID, interface subnet mask, router local interface prior key, hello timer, hello interval, dead interval, authentication type, password, DR, PDR addresses, options, router ID of other neighbors on the link, like this. Okay. Now OSPF state mission. OSPF adjacency process uses 8 states of determine the progress of the. Okay, let me write down here. I think it is there. Yeah, here. Okay. Go outside. Now to become adjacency, remember there are neighbor and adjacency, right? You can become neighbor. After neighbor, you will become adjacency. Yeah. Okay, no problem. This is goes. I told you, right? OSPF is very big. You keep on going like this. Yeah, come. Yeah, yeah. Tell me. Okay. Uh, just a moment. Sorry. Book on order on book actually. The book swing. This book. Arrival procurement department. We shall put the fruits and this. Okay. Next to 9 days. We shall see how it goes. Okay, let's see. Go to the other side. SIC. Okay, so we will start the class, otherwise we take time. Where are we? We are discussing state machine. Okay, now when you say state machine, there are 8 states are there in the process of adjacency. I'm going to teach you, Samir. You want me to answer the question before teaching, or you want me to wait for teaching and then I'll ask questions? No, we'll follow whatever method you want. I'm going to teach you what is state. How many states we have? 8 states are there. Okay, I'm going to teach you that. Right? Right? Shall I teach or not? Last question. See, there are 2 ways. You ask questions and answer, I will not teach. Or I'll teach you, then you ask questions. How you like. Both I am okay. Okay. See, there is one method. Some people study already. No, they ask only questions on these topics. I'll answer that. I'll go next topic. Like that. I don't need to spend time on teaching that. Okay. Which one you want to follow? We have to decide. Now, my plan is to teach you first what is 8 states. Okay. Then any doubts are there, you can ask. Okay. First, let's start. So 8 states are there. So I'm going to teach you OSP of adjacency state machine. So 8 states, if we see, the first state is down, second state is atom, third state is emit, fourth step is two-way, fifth is extract, exchange, loading, full, like this. Okay, 8 states are. Now, let us take one example like this. I'm going to take 2 routers. I'm going to make neighborship first. Okay, always you start with 2 routers, right? Because neighborship happens between 2 routers. 2 routers. First, what happens? Now the interface is down, shut down. The interface is shut down, right? When the interface is shut down, there is nothing is going on coming, right? So that is called down state. The first state is called what? Down state means what? Interface is down. Down state means what? Yes. Interface is shut down or down. Okay, OSP of state machine. Now, why you have to understand this state machine? This is the way neighborship forms. Not neighborship. For troubleshooting will be useful for adjacency. I told you again, adjacency and neighborship is different. What is the difference? Adjacency means, yes, adjacency means I share my LSBD. Neighborship means I just keep you as a neighbor, I give LSS to you, that's it. I will not share my LSBD. I'll share LSS, for example, link up, down, I'll share that with you, but I will not share my full database to you. Okay? That is adjacency. Now, this is for forming a neighborship plus adjacency also, full set. Full. Okay. Now we are going to discuss. First state is this interface, FA0, right? This interface is down, shut down or down. Right? I'll write down very simple logic, so then we'll go to the presentation. It will be easy for you to understand. Better just follow this first. Okay. Now, when I say down, state 1 is down. Okay. I say no hello is sent. Simple logic. The interface is down, so no hello will go. The second state is init. In init what happens? Hello is sent. Now for example take R1. When I type this command show IP Eigrp neighbors, show as servers, show as 2 neighbors, then I'll see the state is init. Okay, if I see the state init, what is the meaning? In R1 FA0/0, hello is going. R1 is sending hello. Right? Now third, attempt. Now it is going to saying boss, I sent hello, right? I receive hello. Simple. You're able to understand this simple method? I receive hello. Now other side is replying for me. Yes, I'm receiving hellos. R2 is giving hello to me. Then that state is called what? Attempt state. First no hello sent. Second I am sending hello, no reply is coming. Now I am getting reply. Attempt state. Now next fourth. Oh sorry, I did something mistake here. What is the mistake? Down, okay, reverse. This is reverse. This is attempt. He is attempting to become a neighbor. Now yes, I am initiating the hello. Initialize. This is correct. So first down, then I am sending, right, attempting. Hello. Now initialization started, means I received the hello. Right? Down, attempt, init. Understand these 3 steps? Right? Now, two-way. Now the neighborship is, I am getting the hello bug this side, I am going to form the neighborship. So for neighborship, I have to happen both sides, discussion start happening. Two-way. It's not only one way. Only I am sending, you are not giving anything to me, and the neighborship will not form. Right? So for that, two-way starts now. So what we do important in two-way, I receive hello packet from the neighbor. They have acknowledged from me. Indicated my router ID in the neighbor's hello packet. Understand? Now two-way started, meaning what? My router ID is shared. Now he is telling me, R2 is telling me, R1, this route, my R1 router ID is there, no, he is my neighbor. Who is telling this? R2 is telling R1 is my neighbor. He added his neighbor data in the neighbors. That is two-way started. So this is one state. This is neighbor state. Understand? When you say neighbor, this is neighbor. That's it. Router ID in neighbor table. Okay. Now this is one level. I am your neighbor now. But next level, if I go, 5th level, when you go adjacency only. Now when you want to form adjacency, otherwise it will be two-way. That's it. It will stop here. In this state it stops, right? R1, R2. Then you just think this is a neighbor. It's not adjacency. Understand? Sometimes you see the two-way also. Sometimes you see neighbor also. Both I will show you where it comes. Okay. So neighborship will form in the 4th state. 4th state. That's it. In the router ID is added in the neighbor table. Right? Router ID in neighbor table. That's it. Done. Neighborship formed. Now next, I want to become adjacency now. When I want to become adjacency, I will start exchanging, right? Exchange has to start, correct? LSBD has to exchange, no? LSBD. LSBD has to exchange. For exchanging LSBD, what do you need? You need to form somebody like something called master-slave relationship. What will happen? Something like this. See, I want to share my data with you, but I cannot share the data with you without forming a master-slave relation. Meaning, I will say who is master, who is slave. For example, R1 is master, R2 is master. Now I will say, now I am going to share my knowledge with you, right? So now before doing that, we need to be very clear who is master, who is slave. Otherwise, you think like you are master, I think like I am master, both speak like whatever we like to speak, fight will happen and we will never exchange any information. You understand? To share any information, we need to be very clear what is master. Master is the one who defines the process. Like I asked you, right? We will go for this method or this method. We will define it. Then we will go for this. I'll teach you the topics first, 8 stacks, then you ask questions. This is a process I am fixing it, right? That's why I am master. You got the idea. When you teach somebody, you do the same thing here. When you teach someone, what you have to say, boss, this is the process we are going to follow. Right? So when I am teaching, I will teach you the topic, then you follow, you ask questions. This fixing the process is master. Now who will do that work? Fixing the process, how to teach, how to first what to teach, what step by step how to go, what topic will cover first. All these things who will fix, he is the master. Here also, R1 and R2 want to share their LSBDs. To share the LSBD, first thing what happens is, they both discuss who is the master. Now for example, R1 is master. Okay. Once R1 becomes master, right, R2 is slave. Now R1 will say, okay, I am master now, I am going to start the process. So this is the one he starts. What next system? Got it now? See, first step for actual adjacency. This is the actual adjacency, starts here. Okay. Now he says master relationship is formed where master has a router. How master is formed is based on the highest router ID. 11112222. Who will become master here? For example, this is my router ID is 222 1111 and 222. Who will become master? R2 will become master, right? Understand? No? Let me change this. Simple logic. Who is become who is age, more age, they will become master, no? In relationship. Because he is old man, yeah, why are you torturing him, you know? Listen to him, no? What he is saying. Okay. बड़ों को बात को टालना मत, you know? Big people are saying, you just accept them what they are saying, do as they want, you know? Master slave. Understand? So that's master, he becomes master. Same way here also, who is the highest already, he will become master. After that, master will start the activity. Now master will choose the starting sequence number. And there is a number he will select. For example, any number, random number, he will select and he will put that in the descriptor and send it. Okay, now there are two things. Now first, once I say master will select, now next is exchange will come. Yeah, exchange. Okay. Now exchange, what happens? He is going to, who is going to send? Master will send. Right? Now he is going to send what? He is going to send the database descriptor. Database send the master sends. Okay, master send the database descriptor. Okay, let me write over descriptor. Now here DBD, otherwise we say what? DBD. DBD means what? What does this mean? It's very simple logic. Now I am not going to give you the full database to you beginning itself. I am going to give you only the table of contents. Like I have a 1000-page book. Like I have a 1000-page book, TOC. Right? I am going to give you table of contents. Okay. Instead of giving the full book Xerox, I am giving you only table of contents Xerox. Now you got my table of contents. What are the details I have in the book? Okay, 10,000 page book, 1000-page book. Okay. Now you send your table of contents. Okay. Who will send? Slave will send. First master send. And why first master is sending? Because it is going to put the sequence number. He is going to start the sequence number. So based on this number, right? Then this guy slave will send them. Up next number he will put and send it. This DPD. Now they both shared their table of contents or DB, database description. Then what happens? Exchange. Then we go loading. Now what happens? Now I know your details, what you have in your book. You know what I have in my book, right? My database. Now you will ask me, sir, can you send me slave request? That is called LSR. LSR means what? Link state request. Okay. Master reply. He will give back. Okay, you want this? Take it. LSU. Link state update. Then this is done. Then next master will request. Master. You have something, right? Give me. Maybe you have this. No, give me that. I'm asking you. Master means. First R1 is asking. Slave is asking. Okay, I saw your TOC. You have this route. These routes are available. These links are connected to you, right? Can you share the details? Yeah, take this. He is giving. Master is giving. Then master is asking. You have connected to these links, right? You have 4 links are connected. No? Can you give me the details? He is giving. R1 is giving. Understand? So master request. LSR. Then slave replies. LSU. Right. Now what happens? Both share the details. Whichever you ask. Understand? No? Not to ask everything. You have already means don't need to ask. In the book, everything you don't know. Only this IPv6 topics you want to learn. Rest all you know. So you are asking only, sir, give me IPv6 only. I give only IPv6 only. But we both have same database end of the day. Right? We both have same database. Clear? Understood this? Okay. Next we'll go to last state full. Here, adjacency form. Understand? You understand this? Clear on this? Session number. Okay, now you write down this, then we'll go to the presentation. Now you'll understand that. This is very, very important. If you don't understand this part, you cannot do troubleshooting on OSPF. So you understand where the adjacency up to 2A, it's only neighborship formation. From 5 to 8 when consistency formation starts. Just insist. Just okay. Okay, we go next. Okay, next we'll go to presentation. Okay, now you can understand this. It states down, no hello is received. Attempt, unicast hello is sent to the neighbor, but no hello is received back. Only used for formal configuration. MBMA neighbors. More on this later. MBMA non-broadcast multicast. Multicast is there. We'll see this later. And in each state, I have received a hello packet from the neighbor. Yes, but they have not acknowledged a hello from me. See, they have to acknowledge, right? How do I know they acknowledge this? They will add my neighbor, my router ID in their neighbor database, neighbor table. You understand? In their neighbor database, if they add my router ID means as a neighbor, then I know they are agreed me as a neighbor. Understand? So two-way means what? I have received a hello packet from the neighbor, They have acknowledged me a hello from me. How do I know? By indicating my router ID in the neighbors hello packet. So whenever they are sending a hello packet, they will say, I am also their neighbor. When I get this information in their neighbor update, right, the hello packet, see in hello packet, neighbor also will come. All the neighbors also will come. In that I see my name, my router ID also in the neighbors, then I know, okay, this guy agreed me as a neighbor. Then next, now this is neighborship formation. Next it starts adjacency formation. When you start adjacency formation, the first step is first master-slave relationship. Why master-slave is important? Because the master is the one who is going to put the starting sequence number for the DPD packets that are used for actual LSA exchange. Next exchange starts. Local link state database is sent through DPD packets. DPD sequence number is used for reliable acknowledgement transmission. The sequence number, remember, used for reliable communication. What is reliable communication? I will send a SYN plus one you add acknowledgement. If I am not getting it, I will resend it again. You understand? One number, for example, 1 I am using. You send 2. 2 means what? 1 I receive. You remember how TCP works? SYN plus SYN ACK. What is SYN sequence number? I will send R1 will send a sequence number of 1. R2 will give the reply back like 2. When I say acknowledgement 2, what R2 is telling is yes, I received your 1 packet. I acknowledged it. Understand? Do you understand this? What is that? Okay, mute. Okay. So the point was, I was sending a 1, you are giving me acknowledgement 2. So for that purpose, we are using these sequence numbers. Okay, for reliable communication. Then the loading starts. What is loading will happen? In loading, what happens? LSR LSU is exchanged. Right? LSR LSU is exchanged, and you send the link state request LSR, and you get a reply for the or whatever information you want. That is real loading is happening. Database loading is happening. Then the neighborship will become fully adjacent, and database are synchronized. Both are having same database. Okay, neighborship form. Next, yeah, done. Now see the same thing we explained here. First, hello, I am sending. It will come to coming now. Now okay. Okay, you just connect, start and connect.
No, I cannot say anything. No, I can't.
Anything.
Only black.
You are connected to this.
Yeah, I'm connected.
Again, try. Yeah.
Yeah, now I can see.
Clear now?
Yeah.
Now, first it is sending hello packet, these attributes, and I am receiving a hello packet. Then the two-way starts. After the two-way happens, then I will start the exchange. In exchange, what happens? I am say I am the master. This is the sequence. Let's use this sequence number. No, no, no. You say I am. No, no. I am. Mine is higher router ID. I will be the master. We'll use this sequence number. Okay. You say okay,
Yeah.
sir. If you are having highest router ID, you will be the master. Okay. Okay. I am the slave. I will accept for this. Then there is the my. This is my DBD. Okay. Give me your DBD. Okay. Both DBDs are exchanged. Then I request you loading path. I'll ask you, can you give me this is the information I want? Okay. Then he gives the reply for that. Same thing will reply for this. LSA of complete information completed. It becomes full.
Yes.
Clear on this?
Let's say information completed.
Can you view that this one? This one. Now we get okay, fine. Then now next, once database is synchronized, part selection begins. Now here is the important part here. Here we are going to study how the now both are having same database, correct? Now the SPF has to run, correct? Now we are going to see how SPF is going to work. See, each router LSA includes something called cost, right? Based on the bandwidth it finds it. The formula is 100 divided by bandwidth in Mbps, right? Now best path is selected to the link based on the end-to-end cost. It will add all the, like for example 5 are the 5 it will add 2 sides, two routes, it will add all the cost and see what is the best path, lowest end-to-end cost. Clear on this? Next step, with distance vector routing, you only know the neighbor's best path, correct? But in link state routing, you know all paths including the neighbor's unused paths. Because you have the tree, right? Okay. So Dijkstra SPF algorithm ensures that all routers agree on the same routing path even though they make independent decisions. See, every router is taking its own decision, but if you see that, there will be no confusion because all are running the same algorithm. When you say this is the best route, I will also say this is the best route because we both the same algorithm, right? So that is called SPF. The final output of this SPF is called shortest path tree SPF, SPT. SPT means shortest path tree. So it will create a tree. Using the SPF, we will create a tree, SPT, shortest path tree. Understand? Okay, now see how it is doing it. To find SPT, SPF uses 3 internal data sets. Now, to reach the SPT, it actually creates 3 stages. First, from the link state database, it will find all paths discovered from the neighbors. Then it keeps on updating the best path, link possible to the shortest path tree. Okay. Then finally, it will put the best path in the tree database. So 3 databases are there. First is all paths and possible paths and the actual path. 3 stages it will be there. Now, once the entries of the candidate and tree database are described individual branches of the tree between 2 nodes, denoted by router ID, neighbor ID, cost, all these things. So example, the branch between R1 and R2 with the cost denoted to 10 is denoted R1, R2, 10. Understand? I want to go to 10. So how I will go? R1, R2, 10. Now the ultimate goal is to build a tree with entries of R1, Rn cost, where n is every node in the topology. Maybe 5 nodes, 6 nodes also. Right. So calculate the shortest path from R1 to everywhere. Like that, you take R1 and for everywhere you create the best path. You put it in the tree. Understand? So there are how many trees we are creating? Link state database, candidate database, right? Then tree database. So from link state database we create a candidate database. From the candidate database we create, finally what output will create tree database. Understand? Now what we are doing here, we are taking the first from link state database. I'll see what all the possible things are available. That is candidate database. See, candidate database. Three database to maintain. See, link state, candidate, tree. Can you see that? Now SPF is running 3 internal data sets to reach the tree. It directly not comes to tree. Understand? Now we are learning how SPF is working. Once LSBD finds all the details, right? All the parts available. Now when SPF will start running, what SPF will do? Take LSBD and it creates a candidate database. What is candidate database? Candidate database is nothing but all the possible links. Not shortest. All the possible links. Okay. Understand? To reach the destination. No, not shortest path. All the possible links. Listen. All the possible links. Forget about this part. What is doing is, it is discovered, all parts are discovered. Now I want to go to some location. I want to find some location. I find it. Now possible links. Possible links. It will find out. Who will find out? Candidate database. Now in this possible links, it keeps on finding the best part. Put it in the tree database. Like for example, I want to go to one location R1. One way is go to R2 and 10. 10 is the last final cost, LD. Final cost. Not LD we don't say. Okay. Final cost. And now another path is R1, R2, R3, 10. 2 to R1. Understand? Different ways are there to reach R1, right? Now this all information will goes to candidate database. From the candidate database, these are the possible links, right? From the possible links, it will put it this best. What is the best one? This is best one, no? It will go to lowest. This is lowest one, right? It will go to tree. This is candidate. Candidate means what? Candidate means all possible links. Remember like this. Candidate means all possible links, and it will be best. Will be keep on putting in the tree database. The final output is tree. So link state is a candidate is a tree. Okay, now see this. Step 1. Start by setting a local router as a route, as the SPF, with the cost of 0. Okay. Find the links to all local neighbors and add them to candidate database. Once the candidate database form, for example, this is one router, this is 0. Then you add 3 routes here, 10, 10, 10. Right? Then take the lowest branch from the candidate database, move it to tree database. Understand this? In this, which is lowest, no, you put it in the tree database. Again, you can overwrite it. I'm not saying it is not the final. Again, if you get any extra route lowest, then you can overwrite it. Understand this? So now tell me 10, 20, 30 is there. So which one will take lowest? This is your candidate. Understand, no? Huh? Your net is slow. For microphone you correct, no? Okay, so you can, the microphone also can connect one connectivity and Okay, you able to see that? See now? Okay. Okay, fine. So first what it does, it creates a roots of 0. From the root, it will find what are the possible routes to reach the local router. Then it put it in the candidate database. In the candidate database, it will find the lowest cost and put it in the tree database. 3 steps. Next, from the branch, it moves to the tree database of the following. Find the remote node links connected to the other neighbors. Move all the links to candidate database, with exception of any to go to the neighbor already in the tree database. Step 5. If the candidate database is not empty, go to step 3. Otherwise, SPF is complete. The tree database contains the SPT. So it keeps on rotating, you know. See, what it does is, the candidate database is the one who keeps on finding the best possible routes. Whichever is best possible route will be put in the tree database. So there are, from LSBD, it will keep on getting the possible routes to candidate database. From the candidate database, it moves to tree database. Again, it will go to the other neighbors and see any other routes are available. To that, it will bring the candidate database, right? Understand? The final output has to be what? If SPF is complete, then the tree database contains the final output. So it keeps on doing this exercise, right? So LSBD, from there it goes to what? Candidate database. From there it's SPT. SPT is the output. Now from there again LSBD will run here, again like this. It keeps on working and put it here. Understand this? Now let us see this. Now they are going to show you an example for this. Once adjacency established in the STP field, OSPF statements track the neighbor topologies. Hello packets are used to track neighbors changes. LSF fields are tracked neighbors. Then hello packets continues to send in the now every 10 seconds or 30 seconds, depends on the network type, interface type. If the hello packet is not received from the neighbor, the date interval, neighbor will be declared under default to 4 times of hello. Hello means 10 means 40 is the dead timer. Okay. Can be low as low 1 second for you can keep that as 1 second also. It is 40 seconds, no? But you can change the hello dead timer for 1 second also for fast convergence. Okay, you can do that. Now sequence number we told, right? Used to track old SLA, new LSA, and age and checksum. These all are used for in the LSA. When you receive a LSA, you see these 3 things: is old LSA, new LSA, and what is the age of the LSA, and what is the checksum. Any error or memory corruption has happened, and flooding will happen. You remember, OSPF does not use split horizon. Remember, because it doesn't use any split horizon. When the change is detected, sends the to all links, even the link it came also. Understand? So not all LSAs require SPF to recalculate. Okay, only example up down event or sequence number change, all these things. So you want to study this too much details, flooding details, there is a RFC available for that. You can study in that. You can study in the RFC. You can more details. Details will be there, like detailed information about step by step how flooding will happen, how LSA packet will go, how it comes step by step. Okay. All things like whatever you want to discussing, right? It will be very detailed and the standard will be standardized document, even authorized document, authorized material about each and every steps. It's available in that. So you can study. You want more learning like CCAE level, no? You want to learn more, then you can go for this and start studying these RFCs. If you study RFCs, it is more on CCAE level. You understand, no? You are learning every step detailed. This is very high level I am teaching actually. This is high level. Understand now? When you think in CCAE level, What I'm teaching is very high level. This is high level, not detail. So if you want to go more details, same thing, more details. In more details, header format, fields, all these things will come in that CC level. Okay, next. Unlike Eigrp OSP behavior changes depends on what type of media it is configured on, right? OSP define different network types. I told you, right? It's a media dependent protocol. Depends on the network types, the character of the OSP will change. What all it will change? How I'll send the update? Who forms adjacency? Like I told, no, somebody will form adjacency only, somebody will be neighbor only. How next hop is calculated? All these things will change depends on the network type. Okay, so let us see that. For example, there are the broadcast, not broadcast, point to point, point to multi-point, non-broadcast, loop back. These are the network types we have. So when you have broadcast, example broadcast means Ethernet. Tell me. You can configure. Yeah, configure. By interface it will automatically come. You can change it also if you want. Command will be there. Okay. Now first we learn this. What is this type? I'm going to teach you that, right? No. What is your question? You can just Samir, I'm going to teach you, Samir. Allow me to teach these topics. Okay. See whatever doubts you have, I am teaching or not. And if I am not teaching the topics what you are expecting, then tell me, then I can add that, right? See, like 8 states, you ask me questions, right? I teach you. Now you have any doubts in 8 states? Same way, you allow me network types now to teach. Just I put the slide now, right? I will teach you this, right? Then you ask me, after teaching these topics, then you ask me, sir, can you do it this way also, can you teach me? Like, right? So, see, there is a syllabus cover to be covered. It may cover your doubts. I'm not saying it will not cover, but let's see if it is covering or not. Because I cannot keep on going CCIE level right now. So I have to cover CCLP level, but if that level will suffice your doubts, good. Let me cover this topic, and after that, if you have doubts, we will discuss on this. Okay? Shall I start? Same thing. Process is same. I'm defining the process. Shall I take the topic, then ask doubts, or in the beginning itself you will ask all the doubts? Same process, right? I'm going to define. So now I'm going to teach you the topic. I've just told you the slides. There are, how many types are there? 6 types. That I'm going to teach you. Let's see you are understanding this. After this, I'll ask you questions. Like I asked, after finishing the topic, I'll stop and ask, sir, do you have any doubts in these topics? Then you can tell me, sir, how to check in that in your computer, how to check in your router. Like that all we can discuss later. Let me first teach you this. Then automatically you'll understand. Your questions will be answered. Okay, let's start first. So first understand the theory part. Then I will show you some demo for all the different types, and I will show you how to configure that, how to change that. That all will do. I will do, right? See, you allow me, I will do. Okay, you don't need to ask this every time, right? I will do all these things. If I miss something, you can ask me. Every topic will be like that only. Even states are there. I have to show you states also, right? We just discussed the theory part. But did I show you any states? Did I show any states that I have to show you? No. Every topic, theory topic, you have a lab. So lab you need to build the topology first, no? To show all these things. Right? So further, what I told you today I'll teach you theory part. Do you remember? In the beginning of the class I told you, today we are going to study theory part. So tomorrow, today evening I'll build the lab, or you also parallelly build the lab, we both build the lab. So tomorrow we will discuss on the same theory part and lab part, right? No? Right? I'm just going through theory parts only, correct? Right? Shall I start? Lab will come tomorrow. If anything missed out in the lab, then we'll see. Okay. Now again I'll continue. So we are going to study the theory part of network types. Okay. So now what are the 6 types I'm going to teach you first? What is broadcast? Broadcast means Ethernet, token ring, FDDA. These are our broadcast network. The command is IP OSPF network broadcast. What is the command? You go to router OSPF1, router OSPF1 and give this command. IP OSPF network broadcast. Okay. Then that particular interface will become a broadcast network type. So where it will come, basically where it's default on where Ethernet, token ring, FDDA. Right. Now sends hello and update messages for all the SPF routers, D routers. What is D router, SPF router? What is it? So there are 2 multicast addresses, right? 224.0.0.5 and 6. What is F6 and what is D? What is SPF? SPF means what? See, I'll show you. SPF router. SPF router. In SPF router means what? SPF router means there are some routers, general routers. What is D router? Okay. D router. So D router means limited router you can keep. SPF for other routers. So other routers will send it to in this option. Only others will send you to this option, and other will be SPF routers. Designated router is 6. Okay. D means designated router. Designated router. These other routers. Okay. In this type, your DR BDR election will happen. Understand? What is DR BDR? This is the designated router where you want to send. Here you understand. Here we will actually talk to one person. We will share only with DR your adjacency. Remember. Now comes here where adjacency forms. With your DR only, the routers will form adjacency. Other router, like for example, I have 5 routers. Like this. Now 3 routers, R1, R2, R3. Now R1 is DR. Now R2 and R3 will become neighbor, but this will become adjacency. They become adjacency. They will share the LSBDs with DR, but with this no LSBD is shared. R2, R3. They become only neighbor, two-way. This is two-way. This is full. You will understand? So this is the command. It defines the what type and what are the medias are supported this type, broadcast type, 3 medias, Ethernet, token ring, FDDA, and it performs DR and BDR election. Here happens. Okay. Next, DR BDR overview they are telling. Used on broadcasting, minimum adjacencies, minimize LSA application, unnecessary everybody will know to send the LSA. Backup router is based on redundancy backup router. DR others are other links. Full adjacency with DRC. It forms full adjacency DR and BDR only. Understand? stop at two-way adjacency. Others will not form full. They will stop at two-way only. Understand? They will not become neighbors. They will just stop full, not full, two-way. So, understand this? Okay. Now see here. Now the same example what I draw in the notebook, they are just showing here. Now, if it is without dr bdr, what will happen? He will send here, 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 here. He will send here, 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 here. He will send here, here. When he sends, everywhere he sends. Understand? Same way when he sends, he will send here, 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 here. Like this, the LSAs will be flooding. It's called flooding. Right? Once dr bdr election happens, what will happen? dr bdr election will happen. Now he is dr. This is bdr. Now I will send only to then this guy will send to everyone. Understand? Right? You got my point here, right? So the how much traffic is reduced? Otherwise, everybody R3, R5 have to send, no? Load means for updates, correct. For updates, instead of sending, you send to everyone, you send only to dr. Okay, so dr. Then dr responsibility, whoever asks, right, he will send it to them. You see, there are two things here. He is not going to